All right, good day, you Calculus 2 people, including all you slackers that decided not to show up today. All right, yes, everyone that's here in the classroom right now is going to get some extra credit points. Thank you. Okay, because there's going to be an extra credit assignment that you will turn in at the end here. Okay, now, but it's one of those things that you have to do here, okay? And you can't say, oh, I had an appointment or something. No, this is the time you're supposed to be in class anyway. All right, so, haha. All right, anyway, all right, find the absolute minimum values of the function. Okay, absolute minimum. Now, maximum minimum. Now, this is a piecewise function, right? Yes. Okay, so in a piecewise function, we have to look at it in pieces. See what I did there? Yeah, in pieces. All right, let's start with the first piece. Okay, what is the derivative of the first piece? It'd be just 2, right? So let's call this one F and call this one G. I'm going to use a different color, like there. So F and G. So F prime is going to be 2. G prime is what? 2x, right? Oh, minus 5. Thank you. Minus 5. All right, that helps me out. Okay, so find the absolute minimum, absolute maximum of this function right here. So I have to check endpoints, don't I? Say yes. Okay, let's start with endpoints. Let's check those endpoints. So endpoints, I would plug in, right? So it'd be f of 0, right? So it'd be f of 0. So f of 0 would give me what? Okay, now other endpoint would be f of 2, which is 3, right? Okay, next one, g of 2, right? I'm checking it, even though it's not equal to, I want to see what it's going to there. Okay, I want to see what it's going to go to there. So g of 2 is going to be what? 4 minus 10, right? 4 minus 10. Yeah, and then plus 9. So you get what? 3. Okay. All right, okay, so we get 3 on that one. Okay, so now let's take a look. So now I have some values right here. Okay, so I have -1. So the minimum so far is looking like it's going to be -1. The maximum looks like it's going to be 3, right?
You also need to check the endpoint 3.
Oh yeah, I didn't check 3. Thank you. So g of 3. Thank you. I know, I was missing something. All right, so g of 3. 9 minus 15, 18, 3? Yeah, positive 3 again, right? Okay, positive 3. All right, so I get positive 3 again. So positive 3. So again, maximum's looking like 3, minimum's looking at -1. Now let's take a look at a couple of next things. So minimum, maximum, we have to go with the derivative, right? So the derivative of f would be 2, right? So at any x value, it's going to be 2. Is there any places in which I'm going to be equal to 0? Say no. There's no places where my f prime will equal to 0. So I know that f prime does not equal to 0. So I cannot do that one, right? That's not going to have any mins or maxes, critical points there, right? Okay, so what about this one right here? So g prime. G prime, if I set g prime equal to 0, I would have a, so g prime is equal to 0 where? Yeah. So g prime at 5/2 is equal to, why, seriously? Man, 0. There we go. Okay. So, I know, right? So G prime at 5/2 is going to be equal to 0. So that means that's a what? That is a critical number, right? That's one of my critical numbers. So that's going to be a min or a max, right? So now I've accounted for almost everything. Okay, I did the endpoints, and now we're checking this one. So now what do I do with my 5/2? Plug it into the original function to see if it's going to be a maximum or a minimum. All right, so if I plug it back into the original function, and that would be for my G, right? So plug in that for my G, and let's take a look. That's going to be, I don't know, I don't feel like, I'm going to calculate that. So 25 over 4 minus 25 over 2 plus, I don't know, let's make it over 4. So that would be 36 over 4. There's my 9. So it's going to be 50. Okay, so this is going to be, what is it? 50 over 4. So that's still a negative. Okay, so that's going to be, let me see, that's 11?
Yep.
Negative 11 over 4? Positive 11 over 4. Yeah, it's positive. Okay, so we know that it's going to be, so G, man, I said G and F still come out. So G of 5 over 2 is going to be a positive 11 over 4. So now, is that more or less than my endpoints? It's less, right? It's less than my endpoints, isn't it? So since it's less than the endpoints, it's going to be like a local. It's going to be somewhere in between. So it's not going to be one of those. Okay, so on that one, that would be a local. So these ends go higher than that. So if it was 12 over 4, it'd be the same as this, right? Say yes. Okay, good. So 12 over 4 would be the same as that. So we know that we're going to have a maximum. Now, where would my maximum of this be now? Okay, would it be at 2 or would it be at 3? Maybe, right? One of them. Is this continuous? Is this continuous? It is continuous, isn't it? It is continuous because we know from here to here it is going to be continuous. This one right here, so when I plug it in there, it's going to be equal. So f of 2 is equal to the same of g of 2. So they're both come out to be 3. So it is going to be continuous, right? But now, what about the slopes there? Are the slopes going to be same? What is the slope at 2? For G, what is the slope at 2? You get -1, right? So we know that F, my brain does not want to say this. So G prime of 2 is going to be -1. And I know that F prime of 2 equals just 2, right? Yeah, the slope's always going to be 2. So what does that mean about that point? Okay, right? Pointy point, the kink, right? So it's a pointy point. So that means that, okay, can I take a derivative at that point? So no. So I cannot take a derivative, but I know that it is continuous. I can't take a derivative. This piece right here, because of these right here, okay, that is going to be one of the criticals that I'm going to have because I can't take a derivative there. It's continuous through all the points except for, you know what, I can't take derivative there. So I can take the derivative at one spot there. So I'm going to have a maximum over here. I'm going to say maximum at 3 because that's one of my endpoints that I'm checking. So I'm going to a maximum at 3 and a minimum at, go ahead, say 0. Yeah, okay. So max at 3, min at 0. How about I start doing some numbers? Because numbers usually help you guys. Or we just play with our phone and pretend like Pacho's not watching. All right, so for right here, we're going to have a rain gutter. We are designing a rain gutter for maximum flow. Okay, maximum amount of water. So we're taking a cross section. So we're only looking at the cross section of it. So if I look at the whole thing, I'd be dealing with the volume. And however long it is, doesn't really matter. We just want maximum flow. So you want the most area out of this. So if I say that I'm going to maximize the area, I know I'm looking for what? Okay, what are the things that I'm going to be working with? Okay, look at what I have here and just think about the things that I have. Okay, so there's a couple things I'm going to have here. So am I going to have a d theta somewhere in there? Yes, we are going to have that. We are going to have that. So we are going to have a d theta. Okay. Are we going to have a d alpha or dA? Are we maximize the area? So are we taking the derivative of the area problem? Yes, we are. It gives us a function already. It gives us a function right here. It looks like it's a mess, but it's really not. So it gives you enough information starting out. So if I start off with area, I know I should end up with a dA dt, right? No, this one's not t. Yeah, because it's not rate of change on that one. All right, so because of this, let's go through and figure out a couple things. So if I'm going to do this, what rule do I have for this thing right here? So I'm going to have that my dA, it's product rule, right? dA, I'm just going to use A prime instead. So A prime is going to give me what? We have F and we have G. So if it's product, F prime would be what? 16 cosine theta, right? Times cosine theta plus 1 plus, what's the derivative of G? Negative sine theta, so I have negative sine theta times F, which is 16 sine theta, right? All right. I lose anyone yet? No. And we're trying to maximize this right here, right? There's 12. There's 12 inches there, isn't there? So I'm going to be folding it here. I have 4 inches on here and I have 4 inches here, right? So I'm going to fold it up. So I know that, do I have another page on that one? No, I don't. So I'm going to use right here. So A prime, so I have 16 cosine theta plus 1 plus negative sine theta and cosine, 16 sine theta, thank you. There we go. All right. So let's go through and actually do some multiplication and put it all together. So it's going to be A prime is going to be 16 cosine squared theta, right?
Yeah.
Plus 16 cosine theta minus 16 sine. That one wasn't me. You guys saw that, right? That one wasn't me. Sine squared theta. Now, what part of this don't I like? You don't like the cosine squared? I was hoping you would say the sine squared. Why wouldn't I like the sine squared? No, yeah, it's not the same term, right? So, since it's not the same term, we're going to go through and actually get rid of it. What can I replace sine squared with? Very good. So I have my Pythagorean identity, which is sine squared plus cosine squared equals 1. And if I want to get sine squared by itself, I would do what to both sides? I would subtract the cosine squared, right? So subtract cosine squared from both sides. So I get sine squared is equal to 1 minus cosine squared. So I didn't use thetas or x's, it's just the identity. So I'm replacing sine squared with 1 minus cosine, right? Cosine squared. Okay, so that's right here for those people that weren't paying attention or forgot about trigonometry. Okay. So trig's your friend. It's supposed to help your math problems become easier. It is, because you don't want to mess with this like this. So I'm going to place that. So it's going to be 16 cosine squared theta plus 16 cosine theta. And it's going to be minus 16 times the quantity of 1 minus cosine squared theta. Distribute. So it's going to be 16 cosine squared theta plus 16 cosine theta minus 16 plus 16 cosine squared theta. Alright, so now combine like terms. Combine like terms and put them all together. So it's going to be, let me see. What else? What can I, yeah. Before I factor, I'm going to combine first. So I'm going to get 32 cosine squared theta plus 16 cosine theta minus 16. Yeah, it's always this too. Now we're going to factor, right? I'm going to factor out a 16 first to make it a little bit easier. So if I take out a 16, it's going to be 2 cosine squared theta plus cosine theta and minus 1. Yeah. All right. Given that, can we factor that? Say yes. Yeah, so it's going to be, if using my method, it's 2 times -1 is -2, and factors of -2, that equal positive 1 is going to be a positive 2 and a negative 1, right? Positive 2, negative 1. I multiply those two together, right? I get negative 2, but add them together to get positive 1. Because my coefficient on my B term, my middle term is 1, is positive 1, but my coefficient on my C term, my last term over here, is a negative 1. So I multiply my first one times my last one to get this. So it's going to be 2 times negative 1, which gives me that. Okay. So now I'm going to replace my middle term. I don't know if you guys, people are looking at me quizzically. Are you guys okay with the factoring? Anyone not okay with the factoring? No? Are we okay? Hey, that guy over there, trying not to sleep. Okay. Are you okay? All right. Okay. So I'm replacing the middle term with what I have down here now. So it's going to bring down 16, 2 cosine squared theta plus 2 cosine theta minus cosine theta and minus 1, right? Okay, factor by grouping, so group those. So I can take out a 2 cosine. So 16 parentheses 2 cosine theta, and I'm left with cosine theta plus 1. And over here, I'm going to factor out a negative 1. Negative 1, I'm left with cosine theta plus 1. So they both have a cosine theta plus 1 in common, right? So cosine theta plus 1. Bring down my 16. And then what's left over? Left over is my 2 cosine theta minus 1. All right, so I have it all factored out, right? I have it all factored out. And now if I'm factoring this out, that means that I'm going to end up trying to find the minimum and maximum. Minimum and maximum, and for this case right here, minimum maximum. So I'm going to set my derivative equal to 0, right? Set the derivative equal to 0, so therefore I can factor things out. So it's going to be 0 equals all this, 16 cosine theta plus 1, and then 2 cosine theta minus 1. Okay, and I ran out of board here. Okay, so I'm going to set each one equal 0. So I'm going to have another page. So 0 equals 16. So that's a multiplier. So right there, that goes away, right? So 16, I could discount that one. And the next one's going to be 0 equals the next part, which was the cosine theta plus 1. Yeah. Okay. Cosine theta plus 1, right? Now, I'm trying to solve for theta, right? Trying to solve for theta, subtract 1 from both sides. And from here, where is cosine, where is theta equal to negative 1? So on the unit circle, so now we're thinking about it in this term. So it's arc. So I'm going to switch this. So it's going to be theta equals inverse cosine, or arc at negative 1. So what angle is cosine equal to negative 1? At what? At pi, right? You guys agree? Pi? Did I lose anyone there? Okay. So hopefully someone had their unit circle out too somewhere, right? Yeah, just in case. No. All right, so now, is that in my interval that was given to you at the beginning? Is that in my interval? No. So if I think about it, the angle theta, if that was all the way at pi, remember, what is pi over 2 in degrees? What is that? 90 degrees. That's straight up and down, right? That's straight up and down. So therefore, if that's straight up and down, what do you think pi would be? Laying straight flat, right? Okay. Okay, there we go. Okay, so it's laying straight flat. So therefore, if it's laying flat, that would be a minimum volume, wouldn't it? That would be a minimum volume. So that's going to take care of that. But it's outside my interval. So if it's outside my interval, I could disregard this. I'm going to disregard this. Now the other piece was 0 equals 2 cosine theta minus 1? Okay, minus 1. Set it equal to, right? So move it over so it's 1 equals 2. I even said 2. Come on now. 2 cosine theta divided by 2, so it's going to be 1/2 equals cosine theta, and do the arc or inverse on this. So theta equals inverse cosine of 1/2. So where is cosine going to be equal to 1/2? Pi over 3, right? So pi over 3. So pi over 3 is going to be the value it's going to be. So theta equals pi over 3. So that's going to help me out. So now that's pi over 3. So now if if theta was my minimum, therefore this one should be my maximum. So here's my maximum, and is it inside my interval? Yes, it is going to be inside my interval. So we have the angle now that maximizes that area. Make sense? Okay, good. Okay, coughing is caused by increased pressure in the lungs and is accompanied by decrease in the diameter of the windpipe. The radius r of the windpipe decreases with increased pressure P, according to the formula R sub naught minus R equals Cp, where R theta is the radius of the windpipe R sub naught is radius of the windpipe when there is no difference in pressure, and C is a positive constant. Okay, the volume of airflow, volume V, through the windpipe, V equals KPR to the fourth, where K is a constant. Find the radius, R, that allows the most airflow through the windpipe. Restrict R so that 0, so R will be, your initial R divided by 2 is less than R, which is greater than, less than equal to R sub naught. So what does that mean? What does that mean? What do we say R sub naught is? Okay. There's no difference in the pressure, right? So there's no difference. So it should be fine, right? That should be your starting, right? Okay, so now we're finding R, and we know R has to be less than that, right? And if we're talking about airflow in a lungs, we have to have a restriction on the bottom, don't we? Can you have less than 0 air pressure in your lungs? Only in space, right? Yeah, that would be a vacuum where you have no air in your lungs, right? So, do we have a formula here for this? Yes, we do. Okay, we do have formula for this, so we have some restrictions on this. Let's go ahead and right here we have a formula. V equals KPR to the fourth. K is a constant. So if K is a constant, that could just stay out front, right? It's whatever constant. So when I take the derivative, that just stays constant, right? It'd be like taking the derivative of pi, or like pi x. That number just stays what it is, all right? So same thing goes for this K. So I have to have, I got a slight issue here though. But since I have a P and an R in here, so can't really do much with that, can I? Say no. Okay, so right here, says K is a constant, and up here it gives us another formula. Okay. Because that other formula there, we could actually replace to actually plug this back in. Okay, and we know, it says right here, where R is the radius of the windpipe, when there's no difference in the pressure, C is a positive constant. Okay, that's a positive constant, right? Okay, the volume of airflow windpipe is V right here. Okay, K is another constant. Find the radius R that allows the most airflow through the windpipe. Restrict R so it's between there. So now we have C is a positive constant right there, and the radius R, I already looked at this and I totally forgot where I was supposed to take it. Because I know I'm going to get R is equal to R sub naught minus CP here. And since that is going to be a constant, I could say right there, I could say that P. So from all that, oh, dang it, yeah, I did it the wrong way. I'm sorry. All right, so we're going to get rid of the P. So it's going to be, let me see, P equals R sub naught minus R over C. There we go. That's what I was doing there. So I have that value, so I can plug those in, right? I'm going to plug those in. So R sub naught is going to be my initial value that I have. So I have V equals K, which is some constant, times P, which I'm replacing with R sub naught minus R over C, times R to the fourth. Yes? All right, so, okay. All right, so now from here, I also have to work this out because I forgot how I got rid of R sub naught. Dang it. Okay, I'm going to pause this. Let's go back to that. Okay, so we have, what did I say? V equals K times R5 over C. So I take V prime, which would be 5K over C times R to the fourth. All right, so because of that, let's go through and actually continue with this one right here. So I have that 5K C. So now from here, I'm going to set this equal to 0. So it's going to be 0 equals 5K over C R to the fourth. So it's going to be, to try and get this by itself, what's going to happen to my R's? So I'm just going to get what? What's going to happen to the 5KC? Yeah, divide by it. What? And then what's going to happen? 0 equals R to the fourth, right? So I'm going to get R equals 0 for this one. Okay, so now let's take a look at what we have because of that. And from here, it's going to be less than my initial. So I have my initial should be, I don't know, I screwed this up somewhere because that's not the number I came up with before.